Hey students, next topic we are going to see is about diffraction in grating. Okay, so we are going to consider the grating in that how the diffraction take place. Okay, first the grating has multiple slits with equal width of size comparable to the wavelength of the diffracting light. Okay, so when you see this grating, it has a equal width, okay, and it has multiple slits in it. Yes, and that will be equal to the wavelength of the light which is being used here. And this grating is a plain sheet of transparent material on which opaque rulings are made with fine diamond pointer. So actually this grating is what it is, a transparent material, and using which we are going to draw a opaque ruling. Okay, so in this transparent material opaque ruling is being drawn with the help of what? Diamond pointer. Okay, and the modern commercial grating, it has about 6000 lines per centimeter. Okay, for 1 centimeter length of grating we have how many lines? Nearly 6000 lines. Okay, so that is the rulings which is made on the grating. Next, the ruling act as a obstacles having the definite width of B, and the transparent space has a width of A. Okay, so it has two width B and A. So one is obstacle, okay, other one is a transparent one. Obstacle has a width what? B, and transparent space has a width of A. Okay, so combine the width of the ruling and a slit. Okay, so this is a ruling and this is a slit. Okay, so combined width of both is called as a grating element. Okay, so we are adding this A plus B. Okay, so grating element is a combined width of the both ruling and slit, and so we are writing E is equal to A plus B. Okay, and the points on the successive slits separated by distance equal to the grating element are called as a corresponding points. Okay, so the successive slit which you are considering, okay, and if you consider many points in this and that is equal to this grating element, then those points are called as a corresponding points. Yes, clear with what is a grating element and the corresponding points? Clear? So this is the diagram we have. Okay, so this is a grating element. Yes, and this is made to pass through the lens. Okay, so from the grating element we consider this to be A and this to be B. Okay, so over this the light passes, yes, and it falls on this. After falling on that, it has been converged to one single point. Yes, so now this can be written as A plus B into sine theta. Here we are making the angle to be theta in this. Yes, clear? Now the plane transmission grating is represented by AB. Okay, so this is a plane transmission grating and that is being represented by the letter AB. Okay, next is let a wavefront. So we are considering only a one wavefront, a plane wavefront, and that has a wavelength lambda. Okay, so consider a plane wavefront which has a wavelength lambda, and as the slit size is comparable that of the length, the incident light diffracts at the grating. Okay, as the length is comparable, it undergoes with a diffraction. Okay, diffraction take place. Okay, and the diffraction pattern what we are doing, it is being obtained on the screen. So on the screen the diffraction pattern is being obtained, and when the diffracted wave focuses on the screen using the convex lens, so with the help of convex lens only we are obtaining with this diffracted pattern. Let us consider the point P, and which is at an angle theta with a normal. The path difference is given by what? A plus B into sine theta. Just we saw in the diagram itself, is it not? That is given by what? A plus B into sine theta. That is a path difference. So next is this path difference is the same for any pair of corresponding points. Okay, and so if you are considering the point to be bright, then we get del is equal to m into lambda, and m takes a value of 0, 1, 2, 3. Okay, so the before equation is what? Just now we saw the equation del is equal to a plus b into sine theta. Yes, the equation which we have got here is del is equal to m into lambda. So combining with these two equations we get a plus b into sine theta is equal to m lambda, and here m denotes the order of the diffraction. Okay, so m denotes the order of diffraction. First condition is if you consider for zero order. Okay, so if you consider for zero order, then m takes the value of 0. Next is first order, m takes the value of 1, then second order, and it goes on. Okay, so substituting those values here. First, zero order means what? A plus b into sine theta is equal to 0. Okay, so for zero order, m is equal to 0, and so a plus b sine theta is equal to 0. Then theta is also equal to 0, because when you take this to this side, sine theta is 0, then theta is also equal to what? 0. Okay, and all the values are 0, so this is called as a zero order diffraction or central maximum. Okay, so this is called as what? Zero order diffraction or central maximum. Next is first order. For first order, m is equal to 1, so m we have taken as 1. So sine theta 1 is equal to lambda. Then theta 1 takes the first order maximum. Okay, so that is a incident light. Okay, so this is about the first order. Then when you consider for the second order, we get m is equal to 2, and so m plus a plus b into sine theta 2 is equal to 2 lambda. Here theta 2 takes the second order, and same way for higher order maximum. Okay, that is for nth order. Okay, so higher order we can write, or that is for nth order. Okay, then we get n is equal to 1 divided by a plus b, because this gives your inverse of the grating element. Okay, so we take with this equation now. So n is equal to 1 divided by a plus b, where n denotes the number of grating elements or the rulings. Okay, so n denotes the number of grating elements or the rulings. Normally this number n is specified by grating itself, so the equation becomes, okay, so what is the equation which we know is a plus b into sine theta, a plus b into sine theta, which is equal to what? M into lambda. Yes, now instead of this a plus b, you bring it this side, n you bring it down, so we get a plus b, which is equal to what? 1 divided by n. Okay, so instead of this a plus b, if you substitute that value here, so we get sine theta, and before that we have 1 by n. So a plus b is what? 1 by n sine theta, which is equal to m into lambda. So we are getting with this equation here. Now bringing this n this side, so we get sine theta is equal to n m lambda. Okay, so this gives a diffraction in the grating. Okay, so sine theta is equal to what? N m lambda. Yes, clear with this? Thank you.